All right, so we're going to wrap up this last chapter on imperfect markets and oligopoly with a discussion of game theory and strategic behavior. So what is game theory? It's this branch of mathematics that economists use to analyze strategic behavior of decision makers. And some of the basic components of a game are there have to be two or more players, right? That makes sense. The players have to have different strategies, and the combination of their strategies have to provide them with various payoffs. And there's two different ways that games can be played. They can be played either simultaneously, which is like tic-tac-toe, where each player reveals their strategy at the same time. Now, it doesn't necessarily have to be exactly at the same time. It could be that, I write rock, paper, or scissors on a piece of paper, and then you do it at some other time. But basically, it's not like chess or checkers, which is a sequential game where we're taking turns making moves. The moves in a simultaneous game are effectively made at the same time, although it doesn't have to strictly be at the same time. It just isn't that the players are taking turns making moves. Okay, so the first game we're going to talk about, really the only game, I guess, actually, because this is the only game that pertains to this chapter in oligopoly and cartel behavior, but you may have heard of this game. It's called The Prisoner's Dilemma. All right, so here's how it works. Two suspects are interrogated separately, and each has the option to confess or keep quiet. So these are the players' strategies. So there's two players. Their strategies are confess or keep quiet. And then the combination of their strategies provide them with certain payouts. So there's basically four different possible outcomes. Either both suspects keep quiet, in which case their outcome is a year in jail each. Both confess, in which case each prisoner, or each suspect rather, gets 10 years in jail. And then the other two possible outcomes are that one confesses and the other keeps quiet, in which case the one that confesses goes free, and the one that kept quiet gets a very harsh penalty of 25 years in jail. Okay, so this is the prisoner's dilemma. And we can represent the prisoner's dilemma in a game table like this. It makes it somewhat easy to analyze. So the way that we look at this game table is we've got our two players. We've got Tony Montana here and Manny Ribera. And you see along next to their names are their two strategies, confess and keep quiet here for Manny, and confess and keep quiet here for Tony. And then we see the different possible outcomes. So in this box, if they both confess, Manny gets 10 years in jail and Tony gets 10 years in jail as well. Here down in this box, this is where Manny keeps quiet, but Tony confesses, in which case Tony goes free and Manny gets 25 years in jail. So that's how you read these game tables. So obviously, right, this outcome here looks the best. This one is what they would like to achieve if they were like, before they committed the crime, they're like, all right, if we get caught, we're both going to stay quiet because we know that if we do that, we'll only get a year in jail. Pretty minor sentence, right? Okay, well, let's see why this is not the Nash equilibrium. All right, so before we discuss further the prisoner's dilemma, we need to talk about dominant strategies and what a dominant strategy is. So a dominant strategy is a player's best choice regardless of what the other player does. Okay, so that's called a dominant strategy. It dominates all other strategies. And so the player should pick that strategy no matter what the other player does. Okay, so that's a dominant strategy. And if each player has a dominant strategy, then it's very easy to determine what the dominant strategy equilibrium is. They pick their dominant strategy, and then you find out what the outcome of each of those players picking their dominant strategy is. So we'll see that in the prisoner's dilemma. Now, we've already talked about Nash equilibrium. And so just to remind you, this is when each decision maker is choosing his or her best response to what the other decision maker has chosen. And it's the pair of strategies, one for each player, so that neither player wants to deviate from their strategy. They don't want to move away from the status quo. So we already saw this with the duopoly example, right? All right, so let's get back to our prisoner's dilemma. All right, so here we've got Manny, right? Now, if he chooses to confess, his sentence will depend on what Tony chooses, right? So if Tony chooses confess as well, Manny ends up with 10 years in jail. But if Tony keeps quiet, Manny goes free. Okay, great. Now, if Tony confesses and Manny confesses, same thing. There you go. And there you go, right? So this is a symmetric game, by the way, so the outcomes are symmetric. But as it turns out, confess is the dominant strategy. Okay, so let's see why that is. Let me get rid of these circles here and show you why that is. Suppose that Manny is thinking about keeping quiet, right? So here are his outcomes if Tony confesses and if Tony keeps quiet, right? Now, if Tony confesses, what would Manny want to do? Would he want to continue to stay quiet? No, he'd want to change to confess because 10 years in jail is better than 25. Okay, well, what if Manny is deciding he wants to stay quiet and Tony also stays quiet? Does he want to continue to keep quiet? No, in fact, he wants to switch to confess because going free is better than 1 year in jail. So as we can see, keep quiet for Manny is dominated by confessing, because confessing is always better than keeping quiet in both cases, regardless of what Tony does, whether he confesses or whether he keeps quiet. So for Manny, the dominant strategy is to always confess regardless of what Tony does. And as it turns out, since this is a symmetric game, it's the same thing for Tony, right? Tony also wants to always confess because confessing is always better than keeping quiet, regardless of what Manny does, right? Confessing is better than keeping quiet. Confessing is better than keeping quiet in both cases of Manny's choices, right? So we have we have players that have dominant strategies. These are their dominant strategies. And so they end up both confessing and both spending 10 years in jail. Well, dang, that sucks, especially compared to this outcome. This is where they wanted to collude and get to, right? 1 year in jail apiece, but it's unstable. So this is a lot like the cartel situation in oligopoly and duopoly. Okay, so we refer to this as a dominant strategy Nash equilibrium. So this is the Nash equilibrium, right? So if this is the status quo, neither player wants to change, right? Manny doesn't want to change from confessing to keeping quiet. That would make him worse off. And same thing with Tony. He doesn't want to change from confessing to keeping quiet either. So it's a Nash equilibrium. And it's the result of two dominant strategies coming together. So that's why it's called a dominant strategy Nash equilibrium. And of course, this is the cooperative outcome they'd like to get to, but they can't get there.